so we're here to commemorate Charles Darwin's 210th birthday. So yes, we're going to party. Hopefully you can stick around till 1:30, and then we're going to cut some cake for him. So what I'm really going to do before we get started is that I just want to acknowledge all the help that I got. So of course this didn't come together by itself. We were a committee of Dr. Adam, Professor Burrow, Dr. Lannon, and Professor Slako. So it's just really wonderful to be at Prairie State. You guys should really know how lucky you guys are to have fantastic faculty to put this together. So we have a special guest, Dr. Graham Slater from University of Chicago. So I think that's really why we're all here. But then if you got a chance to look at the schedule, you should have seen that we also have other Prairie State faculty here today. So we have Professor Dolph from English, Dr. Cornejo from psychology, Professor Montaner from the library, Professor Hughes also from English, and Dr. Thomas from microbiology. So the point is that evolution is one of the most influential ideas in society. It's not just a science or a biology, that it's really touched every aspect of society. Okay, so what I'm gonna do here is just do a really quick primer on evolution and Charles Darwin, so we can cram in what I can in about 10 minutes, and this ironically long title. So I want to just cover a few misconceptions about evolution, because as we know, there are very, very many. And then maybe just some fun facts about Charles Darwin. Oh, and I'm Professor Hung, if you all don't know me. So I normally teach biology here. Okay, so here's who we might picture as Charles Darwin. So I'm going to, so we kind of might think of him as sort of this armchair scientist. I think we see him like sitting by a fireplace, thinking carefully about all these things. So a common misconception about him is that he was always an old man. But really, Charles Darwin was once your age, a college student studying things like biology and geology. So as I've stated before, today would be his 210th birthday. So he is an old person if he were alive today. But when he was a nice young person like you all here, he embarked on a long unpaid internship. So just keep in mind that to get your path on your careers, you all have to do your internships. So his internship was a 5-year journey on a ship that we call the HMS Beagle. And this sailed across the world, like all the way around. So what was going on at the time is that we really did not know the geography of the world. So the Beagle set out to chart and map the coastlines of India, Africa, and South America. So at the same time, naturalist was the old school term for biologists. We didn't have real biologists then. So naturalists are people who like to go outside and look at what specimens and life forms and try to name them and categorize them and collect specimens to send back to England. So Charles Darwin is an Englishman. Yes, so the 1800s was a period of European exploration and colonization. So we tend to, when we hear Charles Darwin and or evolution, we kind of think of the two together. So a common misconception is that he is the first person to propose that species evolve or that they change. So apologies to my past students who heard these slides. But he's actually not the first person to start getting this idea. So there are a few early thinkers. So as I said, a lot of naturalists were studying and collecting specimens from the natural world. And so the more data you collect, the more that you start to see these patterns. And we started to see patterns of changing species. So Georges Louis Leclerc predates Darwin by about 100 years and already published this lovely series that describes all the things that he collected and saw. And then he started to have these ideas that species could change. Charles Darwin's grandfather, Erasmus Darwin, was also an early progressive thinker. So he developed this little phrase, e conscious omnia. So the things that he liked to study were shells. Shells fossilize really well, hard parts fossilize well. So if as you guys saw in the next room, bones, shells, and things like that, we have a pretty rich fossil record. So as Erasmus Darwin was studying these fossils, he also started to have these ideas that, so e conscious omnia means that from shells, everything. So he started to think that a lot of our ancestors could be traced back to these early mollusks. Okay. So then students are supposed to know this name. Jean-Baptiste Lamarck is the first person to actually propose a mechanism. So we had these ideas that species could change. Well, Lamarck is the first person to actually give us a how and a why. So here's now the diagram that we kind of call Lamarck's giraffe. So this story is a way of explaining how giraffes got a very long neck. So the idea goes that if we start on the far left side, we have these giraffes with kind of short necks. They were kind of hungry and they were looking up at these tall trees and they thought, ooh, I wish I could reach. So then they stretched their necks and they stretched out their tongues until they could reach. Then this giraffe with a stretched out tongue or stretched out neck then gave birth to babies with long necks as well. Then they thought that I can reach a few more if I stretch my neck. So then we had longer neck giraffes giving birth to longer neck babies. So then this goes on until we have these giraffes with these 10, 12-foot necks. However, I always go through this because today we know that this is totally bogus. This is absolutely not how it works, but it's a very common misconception that this is how evolution works. So the problems with these is that evolution is purposeful. These are all misconceptions. So evolution doesn't work with something thinking that I want anything or for any particular end goal. So the other problem with this is that individuals themselves cannot evolve. So whatever physical changes are going on to an individual within its own lifetime cannot be passed on to its offspring. So there's a little bit of but there, but for our intents and purposes, there's not a way for so you can't go to the gym, pump up, and then have really pumped up children. So that's kind of the analogy to this. So this also kind of encapsulates the idea that species are always improving, but there really is no like best or better or goal. So as a species evolve as fits the environment at that particular time, and so that might not make sense at some future point in time. So an example of that is obesity in humans, that it used to be advantageous, it used to be good and beneficial for us to pack on fat because we didn't used to have endless calories at the grocery store. Today, food is overly abundant, so it is kind of an evolved behavior that we want to just eat sugary foods, and then our bodies are kind of designed to hold on to those calories for the long term. So we have to call that a gene-environment mismatch. That's another day, another time. So again, these are common misconceptions. Tell all your friends this is not how evolution works. So what did Darwin do is that he collected tons and tons of evidence. So we always argue from a point of evidence. Darwin proposed this idea in Victorian era England, which means that religious views dominated society, and so he knew that he was going to get a lot of opposition. So he knew that it was important to have a lot of evidence to back up his claims. So we might have heard of his book on the origin of species. This is where he presents his evidence, and he was so concerned with this fact. I'm going to skip through these little known facts, but this is like a common edition, is around 500-600 pages. But if you read like the very beginning, he says, this is just a brief overview of a larger body of work that I will publish one day. And then he also published this about 20 years late, so he, like many of us, kind of put off doing things that we should do at a time. So I'm totally running over my time. So this is how natural selection works in contrast to Lamarckian evolution. So we're going to look at these giraffes again. But this time we started with the group of giraffes. And if you look closely at these giraffes, we have a couple with shorter necks, a couple with longer necks. So we start out with a group that has some sort of variation, heritable variation. So those ones with longer necks, they sort of could already reach those taller trees with that abundant food source. So then they had more babies. This one dramatically shows a dead giraffe. It doesn't have to be the case. So these longer neck giraffes, they inherently had that was already in their genetics. So they grew up already with longer necks. So then they have more food, they produce more babies. Keep in mind, babies is the answer to everything in biology. So then those offspring inherit a longer neck. So over many generations, we're only talking an inch here, an inch there, but over many generations, this builds up to that 10-foot neck. So this can take millions of years. This does take millions of years. So here's the whole thing. So kind of an idea that a lot of my students get, though, is that natural selection is out to kill everything. That's not the case. Natural selection just favors whoever has the most offspring. So whoever gets 5 babies versus 3, that is advantageous. We don't necessarily lose shorter neck ones, they just don't have quite as many offspring. So over many generations, then it's predominantly tall giraffes. So Charles Darwin was not alone in this endeavor, so what kind of kickstarted the actual publication of natural selection was Sir Alfred Russel Wallace. Wrote Darwin a letter and said, I have this idea, what do you think, is it stupid? And then Darwin read it and was like, oh crap, this is exactly my idea, so I need to publish. So what they did was that they ended up publishing this together. So who the heck is Sir Alfred Russel Wallace? He's kind of an underdog in all this. So he's also a naturalist who went out and traveled far and wide across the world. But unfortunately, his travels were not as smooth as Darwin's, so he lost a lot of specimens. But here's one interesting little critter that he found. This is now called Wallace's flying frog after him. So there are a few left today, and I just really love that his illustration looks exactly like the photograph. So cameras were not always a thing either. Okay, so then they published, as scientists do, in a scientific journal. So the first publication of natural selection is a journal article in the Linnaean Society. So today we recognize biological evolution. We borrowed Darwin's term as descent with modification. So this tells us that all forms descended from an earlier form. In every generation, there's a little bit of a modification. So there's a little bit of a change. And this gives us the biological diversity that we see today. Okay. So keep in mind that there are a lot of these wild misconceptions, but evolution, when you really look into the facts and the data, that it doesn't match up with some of these kind of bogus arguments.